Hi everyone, today's lesson will be on factoring by grouping. We usually use factoring by grouping when we have 4 or more terms. All the examples below will have 4 terms, however in class we will do examples that have more terms. Okay, let's start with example number 1. The steps are above here, which I will read as I go through the example. So step 1, check for GCF of all 4 terms. Is there a greatest common factor for all 4 of these terms? The answer is no. I mean, some of you might be thinking I can take out an x squared, but there's no x here, so I won't be able to do that. So now I'm going to go to step 2. Take out the GCF of the first 2 terms. Okay, the GCF, if you look, would be x to the 4th. If you need to write the GCF like this, that's fine. Remember, it goes on the outside followed by an open parentheses. What I'd be left with would be x squared minus 2. Okay, step 3, bring down the middle sign. So I'm going to bring down a plus. And step 4 says take out a GCF of the last 2 terms using the sign in step 3. So let's look at the last 2 terms. What number can I divide 3x squared that I could divide 6 by? And you should be telling me 3. And what do I mean by use the sign in step 3? Means we're dividing out a positive 3. And that's important. You'll see why I wrote that. Some of you are probably thinking, why is that necessary? But you'll see in a minute. So when we take out the GCF followed by an open parenthesis, these will cancel. I'll be left with x squared, and negative 6 divided by 3 is a negative 2. Now the last step, take out the binomial GCF. So now between this term and this term, what's in common is x minus 2. So we take out an x minus 2 followed by an open parentheses, and what I'd be left with would be x to the 4th and plus 3. So this would be my final answer. Okay, let's try another one. Example number 2. First things first, is there a GCF of all 4 terms? The answer is no. Okay, now what is the GCF of the first 2 terms? I see that I could divide them both by 3, and I see that I can divide them by x squared. I'm not going to write the GCF underneath like this. I'm going to try to do it a little bit quicker and do it in my head. But if you need to write that, feel free to do so. So I'm just going to write it like this. Take out a GCF of 3x squared. What am I left with? Well, I'm going to do 6x to the 3rd divided by 3x squared, and I would get 2x. Then I'm going to do 3x squared divided by 3x squared and get plus 1. Then I'm going to bring down the middle term, which is a plus sign, and now I'm going to find the GCF of these last 2 terms. Now, there's no letter that I can divide, but it seems as though there is no GCF. When that happens, the only number that you could divide them both by would be 1. So now what we're going to do is we're going to do 2x divided by 1 and get 2x. And we should get 1 divided by 1, and we get positive 1. Okay, now that we did that, we're going to see here on this step that there's a GCF between these 2 terms. The GCF is 2x plus 1. So we're going to write that as 2x plus 1. And what's left over inside would be this and this. So 3x squared plus 1. This would be my final answer. So basically, example 2 did it in 2 steps, where example 1 I kind of did it in 3 by writing the GCF underneath. If it's easier for you to write it underneath so it's clearer, by all means do that. Okay, let's try example number 3. Is there a number that I can divide 10, 15, 6, and 9 by? At first I'm thinking maybe 2, but then I see that 15 and 9 you can't divide by 2. Okay, how about 3 maybe? Because 15 and 9 can be divisible by 3. Oh, and so can 6, but 10 can't. Okay, so no GCF. So we're going to do exactly what we did in the first 2 examples. Find a GCF of the first 2. So the GCF of the first 2, I believe, would be 5x squared. What would I be left with on the inside? 2x minus 3. Now I'm going to bring down the middle term and find the GCF of those last 2. The last 2, the GCF, I believe, would be 3. and I have an open parenthesis, and then I do 6x divided by 3, and I get 2x. Then I'll do 9 divided by 3, or negative 9 divided by 3, and get negative 3. So these two parentheses must be the same in order for you to finish and take out that GCF of 2x minus 3, and I'd be left with 5x squared plus 3 left over. So basically what's happening is this one and this one form a GCF, which I put out here, and after I divide it, I'm left with this and this to form the other set of parentheses. Okay, let's try example 4. Okay, I look and I search first for a GCF. I see only x's and y's. I see an x, an x, y, x, y, y. Okay, so because there's no x here and there's no y here, I can't take out an x or a y. So we're going to do no GCF, but we're going to go straight to grouping. So what's the GCF between these two terms? X squared. What am I left with on the inside when I do the division? X to the third divided by x squared is x, plus x squared y divided by x squared is just y. Now I'm going to bring down the minus, bring down the term in the middle, and now let's take the GCF of these two. The GCF of those two I see as y squared. Now I'm going to do some dividing, and now this is where it's really important. The negative xy squared, you're dividing by a negative y squared. So this negative divided by this negative becomes positive, and you'd be left with a positive x. Now here, a lot of you would take this sign and put it here, but if I put this minus sign here, it's going to be different than this sign here. And remember I said before, these two have to be the same inside the parentheses. So if I'm doing a negative divided by a negative, that's where my positive comes from. So please make sure we're being careful with the signs. So let's star this one, because this is the only one so far that's had this negative here on the inside. So just to recap, we're doing negative y to the third divided by the negative y squared, which gives me a y. So now they are the same. I can write it on the outside, followed by an open parenthesis. Then I'm left with x squared minus y squared. Now normally we would say we're done, but you actually, with this example, can see that I can factor a little bit more. This x squared minus y squared should look familiar to you. This is a difference of two perfect squares. So this is dots. I can make this x plus y times x minus y. And then I just would bring down this first term of x plus y. So technically that last row here would be my final answer. But I can actually not factor anything, but rewrite. What is x plus y times x plus y? You should be saying, that's the same thing as saying x plus y squared. And then we bring down this x minus y. So x plus y times x plus y became x plus y squared. And then we just brought down that last term. So that would be my final answer. I'm just going to erase that. Okay, let's try example number 5. Is there a GCF that I can divide each one of these terms by? Well, x and y, x and y, x and only, and y only. So no. So there's going to be no GCF here. Okay, so let's take the GCF of these first two terms. And I believe it would be xy. And I would be left with x plus y. Bring down the middle sign. And I would take a GCF out of here, which would be negative 5. So now notice, we're going to do a negative 5x divided by a negative 5, which would give me x. And again, we're not going to just take this sign and bring it here. It's going to be a negative 5y divided by a negative 5, which is a positive 1y. Remember, negative divided by a negative is a positive. So now these two are the same. So we're going to take out that GCF of x plus y, followed by an open parenthesis, and we'd be left with xy minus 5. And this would be finished. Okay, why don't you try example number 6 and then hit resume to see if you got the right answer. Okay, so I look first in number 6, and there's no GCF, so I'm going to go straight to factoring these two by GCF. The GCF that we'd pull out would be an x squared, and I'd be left with 2x minus 3. I would bring down the minus sign, take out a GCF of 8x and 12, and I would take out a negative 4. So I would have negative 8x divided by negative 4 is positive 2x, because a negative divided by a negative is a positive. And then I would do 12 divided by 4, and I would get, 12 divided by negative 4, and I would get negative 3. So now these two are the GCF. I pull those out, followed by an open parenthesis, and you should be left with x squared and minus 4. If you circled this, unfortunately it's not simplified enough, because technically this x squared minus 4 is another dot. It's a difference of two perfect squares. So this would be x plus 2, x minus 2, and then I can bring down the 2x minus 3, and then that would be my final answer. Okay, so tomorrow in class, just to give you a heads up, what we're going to do is we're going to do examples that have more than 4 terms, and we're going to do examples where you have to take out a GCF first. So make sure you review this all over again tonight and come in with questions tomorrow. All right, have a good night.